Look at the sheer structural complexity of a creature like the Tyrannosaurus rex. It takes billions of precisely organized cells to build the bones, the teeth, and the muscles required for a massive apex predator to hunt. Modern biology is a masterpiece of complex engineering. 4.5 billion years ago, the planet was entirely alien. There was no biology here, only a hyperthermal rock covered in erupting volcanic cones and flowing lava, bombarded by solar radiation. This diagram maps the composition of that early atmosphere. You'll notice a total absence of oxygen. Instead, the air is a toxic cloud of methane, ammonia, and water vapor, hovering over a lifeless volcanic landscape. Yet every single living thing on Earth today, from oak trees to blue whales to humans, can trace its physical lineage directly back to this boiling inorganic sludge. At some specific point in deep time, inert molecules arrange themselves into self-sustaining biological systems. Identifying the exact catalyst that triggered this transition remains the core objective of origin of life research. The primordial ocean contained all the necessary chemical ingredients for life, floating freely as a loose soup. But ingredients alone do not cook themselves. They required a massive influx of energy to force those isolated atoms to bind together. In 1953, a chemist named Stanley Miller decided to build a miniature version of the early Earth in a laboratory. He constructed a complex network of sterile glass flasks and filled them with the exact gas mixture of that ancient toxic atmosphere. This schematic details his closed-loop system. Miller boiled the soup to vapor, driving it into a chamber where an electric spark simulated lightning. Cooling the vapor, he found the dead gases had fused into amino acids, the essential building blocks of biological life. The experiment proved that a standard combination of common gases and raw electrical energy is fully capable of manufacturing biological building blocks out of thin air. Still, a pile of amino acids is merely a collection of loose bricks waiting for a mason. To be useful, they have to be assembled into precise configurations. In the center of this diagram, simple compounds link up. This chemical stacking eventually forms the twisted ladder of the DNA double helix. Illustrated on the far right, DNA unzips down the middle, pulling floating chemicals to build a perfect complementary copy. One molecule becomes two perfectly identical molecules. This physical splitting and copying process is the earliest instance of reproduction. The moment a chemical structure can successfully build a copy of itself to survive the next generation, dead chemistry upgrades into living biology. You might reasonably wonder how we can be so certain about invisible, microscopic chemical reactions that took place nearly 4 billion years ago. To verify these chemical models, researchers set out to find physical evidence in the field. They focused their search on the oldest exposed sedimentary rocks on the planet, specifically targeting isolated formations in Greenland and Western Australia. Deep inside these rock layers, electron microscopes revealed exactly what the chemistry predicted. These images show the fossilized remains of primitive, single-celled algae. They are the actual physical imprints of early life structures, frozen in deep time. We can even watch these ancient processes happening today. These rocky structures sitting in shallow coastal waters are called stromatolites. They are living colonies of simple bacteria, continuing the exact biological engineering that started billions of years ago. The physical record of life's beginning is stamped directly into the Earth's crust, providing a verifiable geological history of these early chemical events. Over the following eons, those microscopic algae colonies scaled up into the complex biological machinery that powers modern animals. There is a philosophical thought experiment that says if you give a room full of monkeys typewriters and infinite time, they will eventually type out a Shakespeare play by pure random chance. Assembling the genetic code out of a toxic ocean feels very much like that. Shuffling blindly through millions of atomic collisions to perfectly arrange a self-replicating DNA molecule without a blueprint is mathematically highly improbable. The odds against that perfect sequence coming together are staggering. Yet the fossilized cells buried in Australian rocks prove that despite the mathematical unlikelihood, it happened anyway. Every biological process operating inside you today belongs to a single continuous chemical chain reaction that ignited in the primordial ocean 3.8 billion years ago. We are the ongoing result of that original improbable event.